So this is topic 6, probability. So in this chapter, which is your chapter 6, guys, so basically probability, there's I think much of formulas here. It's, so probability got two parts, which is example. First part is with replacement. Second part is without replacement. So this is only two things that we're going to learn in this chapter 6, with replacement and without replacement. So if you look at the first question, your first question is basically with replacement. So what is mean by with replacement? That means, for an example, if you look at this question, in a sample of 10 letters, okay, when you pick up a letter, when you take out the letters from these 10 letters, it will still remain as 10 letters because it will be replaced. If you take out one and then it will replace again, if you take out one and it will be replaced again, so it will remain 10, it won't reduce, in other words. So with replacement means the sample will not reduce, in other words, okay, will not reduce. So that is the idea here, will not reduce. So what are the things here? Look at this, 3 of these are brown, 3 of these are brown, and the remaining in white. So the remaining is 7. If 2 letters are, this is very important, they want you to pick up 2 letters are selected, okay, so 2 letters selected with replacement. Look at that, with replacement, find the probability both are white. So what happens here, very simple. Before we start, a small working. So for the brown is 3 out of what, 10, and for the white is 7 out of 10. So what happens here, this is become 0.3 and this is become 0.7. So that's the idea here. So change it to decimal because that will be easier with to calculate. So A, in your part A, they want both are white. So they already told you, they already fixed it here, it's already fixed, both are white. So both are white means you must take 0.7. So 0.7 times 0.7. So that will give you the first answer, 0.49, because they already told you both are white. Simple. So when it comes to B now, in your B, exactly one white, that means one is white, another one is brown, okay, plus another one is brown, then another one is white. When it comes to probability, you must think what is the maximum outcome you can go for, maximum. So it can be maximum, they said you only can select, remember, back to the basic here, you must select only 2 letters, remember, 2 letters, that is the required, this is the required. So what happens here, when you select, it can be either white or brown, or it also can be brown or white. So this is the maximum probability, in other words, maximum probability. So you must think, what is your maximum that you can go for? This is the maximum. You cannot have another one, because if you have another one, it come back to the first one. So you only have maximum two outcomes here. So what will be the answer? So your answer should be 0.42. Check. Are we okay, guys? So this is how you do. Or if you already know that, okay, you know that if you're already expert and you already know that 0.7, 0.3, and it can be 0.3 and 0.7, you already know that there's only two outcomes, correct? So there's only two outcomes. So you can do it this way: 0.7 times 0.3 times 2, because there's only two outcomes, which is also you will get the same answer, which this is a shortcut. Okay, this is shortcut. Now if you're expert, you can do this way. See, none is white, that means all are what? Brown. All becomes the brown. So 0.3 times 0.3, that will give you what? 0.09. They already told you none is white, so all must be brown only. Now at least one white. Now when it comes to at least one white, you must start with one white, and the maximum it can be goes to what? Two whites. So what happens here is actually one white, one brown, one brown, one white, plus both can be what? White. So what happens here is actually one white, one brown, one brown, one white, and both can be white. Maximum. This is the max. So you start with one white and you go to the what? Maximum. It can be two white. Maximum. This is the max, huh? Okay, maximum. That's all. So you start with one, at least one, and it can be another one, and it can be two. So maximum. So what is your maximum here? So this is how you do it. So that will give you the answer, which is 0.91. Check. Okay. Okay. Or there's another way of doing it. You already know that you must start with one white and the maximum can be two white, which is this part we already done over here. Look at this. This is one white, correct? We already done. So which is this answer, 0.42. Two white, which is what we already done here. This is two white answer. Okay, so the shortcut is actually, you can also do it this way. You just can take the answer 0.42 plus 0.41, that will give you 0.91. It's also acceptable in the exam. This is a long way. This is how it's actually showing how you get this 0.91, but it's actually you already done these two. Okay, so that's about question 1. Now next, question number 2. Now in question number 2 is the same thing. In a sample of 20 items, look at that, 20 items, 5 of these are defective. If 3 items are selected with replacement, again with replacement, find the probability. So they already told you 5 are defective, so another 15 is what? Non-defective. Now the balance you have to find by yourself. Okay, this is defective means another 15 is non-defective. So as usual, do a small working here. So defective, the defective is 5 over 20. How much? The ND, non-defective, will be 15 divided by 20. How much? So you will get 0.25 and 0.75. It's easy a bit if you change it to decimal. A, look at that. All 3 are defective, so it's quite straightforward. Okay, so remember the required is you must select 3 items. That's required. Must select 3 items, so that's required. Previously in your question number 1 it's 2 items, this is 3 items, so you must do 3 times. So 0.25 times 0.25 times 0.25, and this will give you the answer. Which is 0.0156. Or you also can do this way. You already know that you must do 3 times. There's another one more shortcut. 0.25 power of 3 also will give you the same answer. Okay, next B. Look at that, only 2 defective. Now when it comes to only 2, the means is what? 0.25 defective, 0.25 defective, another one is what? Non-defective. So defective, defective, non-defective. But remember, you must go for the maximum probability plus 0.25 times 0.75 times 0.25 plus 0.75 times 0.25 times 0.25. Okay, that will give you the answer. So what have been defective, non-defective, defective, non-defective, defective, defective. So that's a maximum. Okay, you must find the maximum probability or the maximum outcomes. Okay, so that will give you the answer. How much? So that will give you 0.1406. Correct. Or you can use the shortcut where you already know that 0.25 times 0.25 times 0.75. If you look at all the three outcomes, you have the 0.25, 0.25, 0.7. It's just that moving. It's only got one here, another two is defective. You can see in all the outcomes is the same. It's just that moving three times. So it just times what? 3. That also will give you the same answer. C. Now, either one is defective. So that means only one is defective. Same thing. So 0.25 times 0.75 times 0.75. Another 2 becomes non-defective. So this is defective, non-defective, non-defective. So it's moved that way. So what happens here is we do the long method and I'll show you the shortcut. So 0.75 times 0.25 times 0.75 plus 0.75 times 0.75 times 0.25. Okay, so this is non-defective, defective, non-defective, 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 defective. Okay, which, how much is that? So this will give you 0.4219. Or you also can do this way where 0.25 times 0.75 times 0.75 times with 3. So also will give you the same answer, which is a shortcut. Next, neither is defective. That means all are non-defective. All are non-defective. So 0.75 times 0.75 times 0.75. So that will give you 0.4219 as well. Check. Or you also can do this way, remember, 0.75 power of 3, also you will get the same answer. Now this is something the previous question, at least one defective, so you must start with at least one is defective. So that means, for example, 0.25 times 0.75 times 0.75, okay, plus, okay, you just copy back. Now this is one defective, am I right? This is one defective, so you need to copy this whole thing here over here. Plus, and then you go for the what? 2 defective, which is this 2 defective. You just have to copy back this over here. Then becomes 3 defective. Now that will give you the 0.5781. Now if you think carefully, do you need to do this long? No need, because you already have this answer, and you already have this answer, and you already have this answer, which is, there you are. This is one defective answer, this is two defective answer, and this is three defective answer. So you just have to put it in here. The first one defective answer is 0.4219 plus 0.1406 plus, and the three defective answer is 0.0156. That will give you the same answer as well, and this is acceptable. Okay, so in your F, I'm not going to do the long way. I straight away going to use the shortcut, because at least two defective, that means you start from 2. So we know that we already have the answer for the F. 2 defective means 0.1406. This is 2 defective answer, plus the maximum can be the what? 3 defective answer. So that will give you the final answer. I'm not going to do the long way because I already show you once on the long way. So that will give you 0.1562. There we go. So that's about question number 2. Are we okay, guys? Okay. So this is how you do without with replacement. Without replacement means it will reduce. The one later on the next part we will do it. Okay, so if you look at question number 3, okay, question number 3, look at that. The probability of man alive is 2/5, okay, alive, and the probability wife alive is 3/4. So what we're going to do here is, this is something a bit different. It's almost same name, but slightly different. Look at that. A man and a wife. Okay. Now, there's two things here: alive, dead. Alive, dead. So what happens here? Alive is 2/5, and this is 3/4. So you need to find the balance. Okay, so what is 2/5? So this becomes 3/5, and this is 1/4. Alright, and change these to decimal easier. So 2/5 is 0.4, and this becomes 0.6. 3/4 is 0.75, and this is 0.25. Okay, change it to decimal. Now, so this is a small working. A, both alive, straightforward. So you must take the both alive. 0.4 times with 0.75. They already told you both alive. So you get 0.3. P, that either one alive, that means only one can be alive, another one is died, so either one. So you start with man alive, wife dead. Okay, so what happens here is man alive, okay, man alive, wife dead. Okay, wife dead, man alive, wife dead. Okay, and then you continue plus now man dead, wife alive. So what happens here is man dead, wife alive. Okay, so what will be the answer? So that will give you 0.55. Okay, now look at that, only one alive, only one. They already specify, okay, they're very specific here, only one can be alive. So who's that? Only one. So if we follow the sequence, okay, man alive, that means, okay, man alive, wife pergi mati, okay, ini mati, because we follow the sequence, man come first, then only wife in this situation. Okay, so we will be happy, all the mans will be happy lah. So here what happens, very simple, man alive, wife die, that's all. Okay, very simple, very specific, very specific. So you get 0.1, that very specific. Neither is alive, both are die, both are die. So what happens here, 0.6 times 0.25, both are die, so you get 0.15. Okay, both are die. So this is how you do question number 3. Are you okay, guys? So this is how you do with replacement. Okay, so the numbers won't reduce. In your next part we will learn about the without replacement.